Greetings, happy coders, welcome back. Here is a late night vlog from me, and I thought I would show you the progress, the second part here. Obviously I did a vlog last week about the various things I was working on in Perils of Willy, and here I am back once more, and as you can see we now have more or less a complete game. We've got this great loading screen which was done by Craig Howard, who did my previous games, and as you can see he's done a great job. So yeah, the first thing to say is that this loading screen is actually designed to be also a little bit practical, because we have the menu, or the, let's say, side panel here, and this part is not used for the game. The reason for that, of course, is that the VIC-20 resolution is a little bit less than the Spectrum one. So the VIC-20 resolution is actually 22 characters across, and that's why this play area, this part here, is the play area. Of course, this is stretched into the 4:3 ratio on the monitor or TV on the VIC, which is why the graphics on the VIC version, you can have a look at that on YouTube if you want, they look very stretched, and it's also the reason how we were able to implement this game into the Spectrum at the correct resolution, have it running at a good speed by only making use of this part of the screen, which is around 2/3, a little bit less than 3/4, something like that. And of course what happens here is that this panel is loaded in as part of the load screen, and then the game plays in here, so we lose this part you only get when you very first load the game, but this part is maintained and kept as a side panel, and that means that this part here doesn't need to be saved in memory, so we save some memory, and we also don't have to load it in every time, so that keeps it nice and easy, and we never use that part of the screen. So that's the reason for that there. Also managed to put the scroller in. Maybe I had that before, don't remember. Added a bit of color, got some credits on there. Of course, I'll just mention the credits here actually. So we've got Richard, obviously, Richard Hallas, who helped build the levels and has been giving me a lot of little bits of advice about various aspects of the playability, little things that need tweaking, things that don't quite work. John helped put the enemies in. Craig did the just turn that sound off. Craig did the loading screen, as I said, and obviously there was mentioned there, I think, Jim Bagley, who just kind of chipped in every now and again. He was a big fan of the original. And have I mentioned everyone? I think obviously I think there's also Mark, who was one of the play testers, so shout out to Mark as well. There you go. Great. Okay, so that's that. That's all done. As you can see, you probably noticed the color change here. So because this panel is literally not used in the whole game, I decided to just have it kind of change every time you go through a level. So I think I've got level skip on. Yep. So I've got a debug mode, level skip, which is not in the full game, but I can basically flick through the levels, and as you can see, each level changes the color. It's just a little bit of extra detail, and all the levels have been tested, all seem to be working, so that's all good. In addition, as you can see here, I've changed the panel. So in Manic Miner, obviously you had the score here, high score here, and you had an extra sort of square for the lives here, which originally I just had 2 heads here, and the plan was always to rearrange this. I just didn't do it because obviously that's the kind of thing you do towards the end when you know that you've got everything else working, and that you know that the project's going to be finished. So that's the point where you start adding the kind of polish. The first thing you do is make sure you can get everything done from a practical point of view, and then once you really feel confident about that, you can start adding in the little details and tidy things up, and that's can take almost as long as the coding sometimes, but it's gone pretty smoothly. And obviously with stuff like that you can also rope a few other people in to help, which is always good. Okay, so not much else to say about that, except, oh yeah, there is one thing here. For example, I noticed that in the original game the character always started here, and sometimes it meant that you would have probably a second or so to react to an enemy that was coming towards you. So although that did keep you on your toes, I decided it would be fairer to spawn Willy generally most of the time in a very safe place, or at least with a place with enough time to decide. So it does it there as well. And I think the next one, yeah, there is a train coming towards him and it will actually get him, but as you can see there's plenty of time to get out of the way. A couple of other things. So one of the differences as well is that the conveyor belts work slightly differently than in the original. So some of them are slightly different. If you were to compare the two levels, you would find that the direction of the conveyor belts has been tweaked just a little. In general, I've tried to keep the flow of the level so that it feels more or less the same. It has the same kind of difficulty and so on. So that's that. I've also, if you remember from the previous vlog, you can probably look at the sprites and see that I've updated. One of the things I said in the vlog was I wasn't happy with the animation of the dog, and well, I still think I could have done slightly better, but it's kind of okay. I'm happy enough with it. It does its job, and it's better than the original for sure. So that's also pretty good. It's quite interesting, really, because it's ouch. It's quite a different game in the end. It turns out once you get playing it, it's really quite a different game to Manic Miner, because you have a sort of more vertical gameplay style when it comes to thinking about how you navigate the levels. That's probably part of the reason why the fall distance is greater, because it allows you then to navigate up and down a little bit more. And obviously the limitations of the number of blocks and sprites also means that the gameplay is a little bit different. It becomes more of a puzzle game where certainly if you're thinking about designing levels for this, which I might have the option to do in the future, it's something where you think about how you can navigate through the area in such a way that it makes it interesting for the player, because the rest of the sprites and the blocks, there's very little variety. Having said that, there is a little bit more variety in terms of there being more conveyor belts and a few other things. So I guess it kind of balances out, really. And after all, the enemies in Manic Miner, although visually they're quite varied, there wasn't a huge amount of variety when it came to the actual behavior of the enemies. Most of them were horizontal and vertical, with a few exceptions. So yeah, okay, we've been through all the screens and there we are. So I thought the main focus of this vlog then would be about the sprites, because I did have to make quite significant changes there. And I'll just move over to the ZX paintbrush and show you a little bit about how the sprites work and how they were implemented. Right, so here we are in ZX paintbrush, and I've laid out just the initial Miner Willy sprite here just to show you something. I actually don't use this graphic in game. I actually use the one that's used from Jet Set Willy, and I've just taken the source of that. But I wanted to show you here how the animation basically works. So if we zoom in here, you can see that I've turned off the attributes. This is how it looks with the color in place. Here we can see the raw pixel data, and so these are all single bits, so pixel on and pixel off. And so we've got 4 squares here, and each square will be filled with a total of 8 bytes. That's because this is 1 byte here, 8 bits, and another and another and another. So 8 here, 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 that means 32 bytes for this square. Now what Manic Miner does, and Jet Set Willy, and quite a lot of Spectrum games, is that as the character moves, obviously you have to take into account that these bytes are going to change. So what happens then is that as the character moves across 2 pixels, then he moves into the next sort of area here, but we're still within that same square there. So we can basically maintain the animation. The next frame will be here, and then if I move along, you'll see, and then the final frame would be here, And then at this point here we can start with a new set, which would be these 4, and that would be here. So the next frame, if you like, just to give you an idea, would be dropping in just there, like that. So if I just show you, I can remove that. You can see just like that I can you can see how that would actually work like that. So that's all fine, and that's basically the essence of the sprite routines in Jet Set Willy. But what you'll probably have realized is that because we're moving 2 frames, 2 pixels across each time, so 2, 4, 6 here, and finally there to get to the next frame. If we have a sprite which is larger than 12 pixels, we're going to have a problem, because it's going to overlap and go into a 3rd square, and that obviously would mean a different drawing routine would have to be implemented. So I can show you that more clearly if I take an example like this dog here, right? So let's take a copy of the dog here. We'll just drag it up, right? So if you look here, we'll start with this dog here, and then we'll move across 2 pixels, 1, 2, and we're still inside this 4 spaces. But if I move it across again another 2, you'll see now we have an issue because we've got 3 squares across each time. So rather than 32 bytes, then this is going to actually be stored in 48 bytes, because obviously we're going from 16 to 24 here. So that is going to cause a bit of an issue, because the draw routine simply won't work. So that means that essentially what that means is that Jet Set Willy or Manic Miner has a limit on the number of the width of the sprite, if you like, as it's moving horizontally. So I can just show you here that with this one we don't have that problem, because if I start from here, we go 1, 2, 3, 4, 5, 6, even 8, it doesn't cross that line, you see. So, and as you can see here, as it is animating, as the head moves forward, each time it's moving forward, the sprite never crosses in this border area. The reason for that, as I explained, is so that the next time that we draw this set of 4, this one will take over from here, and it means we always have a sprite which is occupying 32 bytes of data. So how do we solve that problem? Well, basically we use a method which is again quite common, and it's going to be it was used in AGD, and it's basically a form of masking. So if we start with an image like this one, and let's move it across, just a second, let me just clear that away. Okay, let's say we want to move it 6 pixels across like that. The next frame, of course, will be we'll be back to using only 2 again. So let's imagine that we are here, and we want to store the data within only 4 squares. Well, essentially what we'll do, because we know that this is moving forward and there's going to be a gap here, we can take this piece of the data just here, and we can store it at the back here, like that. And what this means is that when we draw, we can use 2 bytes here, but what we'll do when we draw is we'll start with a mask that takes only this piece, and this piece would be put, let's say, here, like that. Then we would take this piece and we put it here like that, and then we would mask off this part of the data and this part, and we would put it there, just like that. So in that way we're able to store the data in only 32 bytes, which is very handy, simply because 32 being a multiple of 2, or a factor of 2, let's say, it is you're able to basically access the area where the data is stored more easily. Anything which is 2, 4, 8, 16, 32, 64, and so on. Whereas 24 is a little fiddlier to work with, and it's much easier if you store them in factors like that. Okay, so basically that's what happens. Instead of drawing 2, we actually draw 3, but we use the same source here, and then on one of them we mask it this way, and the other one we mask it that way. So we print the first byte, and then we step forward, and we print the second byte, and then we step forward, and then in the data we step backward, and then we basically take it off, and then we print the third part. And that's how you can print like this. And this is important if you have a sprite which is 16 pixels wide and you want to keep it moving across. You'd need a space of up to 24 pixels here in order to do that. Now you can see here that there is a balloon, and this balloon is actually, it's not shifted at all. We haven't moved the data across, simply because this is moving up and down, and obviously if you're moving up and down you're never going to cross these lines, so essentially that means you don't need to worry about any kind of shifting. If I wanted this balloon to move, say, in a diagonal direction or a horizontal, then I'd have to use that same principle, that same effect. And that's one of the reasons why you won't see any diagonal enemies in Manic Miner, simply because the animation is kind of baked into the code to make it difficult to do that. It's also the reason why if you look on Manic Miner, you'll see any enemy that moves horizontally will only be a specific width in order to fit always inside two character squares across, no matter what animation frame it's held in. So obviously with Perils of Willy, as you will have seen, we have to solve that problem, because the graphics, such as the bird here, as you can see, and the train and the dog, are all wider than 12 pixels, which means we have to essentially reconsider the way that, well, rewrite the way that the sprite routine is done. And that's done, as I've explained, by allowing it to draw 3 bytes. So let's take a look at the sprite editor, and I'll show you how I go about creating these sprites so that I can then export them for use within the game. So here I am inside AGDX, let's say, and the sprite editor here is set up for 16 by 16 pixel sprites, which is ideal for working on a game like this. And as you can see, I've got the bird here, and I can basically make it animate like so. Now obviously, as I explained earlier, in order for this to be displayed properly within the game, we need to consider the shifting. If we were to use this animation, it would not be compatible, simply because as soon as you try to move it 2 pixels or 4 pixels or 6 pixels to the left or to the right, then it wouldn't be able to display it correctly, because it would require an additional character, as I previously explained. It would be fine if it was moving up and down, as this balloon does, no problem. But in order to make this work properly within the game, we have to shift it. But fortunately, AGDX has an option which allows you to shift an image to the left or right, like so. So it's quite easy to do, and that's why I work within the editor to create the sprites. Once I've got something that I'm happy with, like this, all I have to do is start with frame. As you can see, there are 4 frames. Start with this frame, go to the next one, shift it across 2 bytes, go to the next one, shift this one across 4 bytes, this one, like that. And basically, if we go back now, what you'll see, if you watch the animation, imagine that there is another frame in here, right? And it's a kind of wraparound effect. So as this one goes forward, you'll step forward like this, and this part will be here. This part will be printed here. This part here, and then we'll be back here. But by this time, this one will be one square ahead, and so the animation will continue. And you can see that's essentially how that works. It doesn't look great from here, but once it's in the game, it works exactly as it should. I have to do the same for the animation on this side, and it's the same shift. It doesn't matter which direction the animation is running. We do the same principle of shifting as we would. So we just shift it across 2 spaces. This animation 1, 2, this animation 4, and this one. So the reason for that is that we'll be looking whether the sprite is moving left or right. It's going to have a coordinate at which it starts, and that will have an offset of either 0, 2, 4, or 6. So it'll know where it's going to have to start drawing from. And so, as I said, it will draw this section here, and then the middle section, and then the third section, just like that. So essentially, yeah, that's basically the key to that. In this case, 1, 2, 3, 4, 5, 6 here, and this part will be 2. So it would start with 2, and then 8 bytes here, and then 6. Whereas this one would be 4 bytes from here, and then these 8 bytes, and then these 4 here, like that. Alright, so that's essentially how that works, and that's the secret of being able to add full-size sprites, full width, horizontally moving sprites into the game. The same principle. If you look, I'll show you the dog here. You can see the same thing happening with the dog. It uses the same shifted animation, as you can see, as it's moving along, like that, and the train does the same principle. Alright, so how do I get that into the game? Well, basically there are 2 things I can do. One of them is that AGD has an option to export to assembly, which is fine. It can output source code, but I'm using an earlier version, and that doesn't have that option right now. But there is a nice easy way. All I do is I generate a sprite sheet like this, and all I have to do then is save this image as a screenshot. I then load that into ZX Paintbrush, and following that I can then output from ZX Paintbrush, and I'll show you that now. So we'll move back to ZX Paintbrush here, and we'll zoom right out like this. Just a second. Okay, there I am zoomed out. So what I'm going to do here then is, this is taken from the graphics where I generated a screenshot. Obviously I've been playing about with this, but basically I can copy and paste the sprite data, and you can see here I can highlight this like that, and then what I do is export it. So I highlight like this. There's an option within ZX Paintbrush which I can bring up here. Oops, just a second. File. Okay, so I'll change this to binary like this, and then I'll put Perils sprites here over right, and basically, yeah, I just need to choose block-based output, 16 by 16. Don't include the attributes, and incidentally, there is an option. I believe it will actually give you the option not only binary but assembly. I think it does allow you to do that, but normally I just export as binary, and then just include it within the source code like that. So I will just basically save it off like that, and I can show you in the source code. Just a second. So here you can see this is a data area, and this is the sprite data. This is the Jet Set Willy data which I imported, and here you can see that there is a file here, new sprite data, and Peril sprites 1 and 2, so there's a second row of sprites there. That's how the code can access that, and basically as soon as I save out this file, then I don't need to change the source code at all, because it's referencing the binary that I've that I've already exported. So the minute I export it and then compile, it will go straight into the game. So yeah, and let's take a quick look at the draw routine as well, just a second. So this is the part of the source code that draws a sprite. I'm not going to go into the full details of getting the source address and the screen address and all of those kind of things, which perhaps we'll do in a tutorial video at some point. But essentially we're going to store the screen address. The where to draw it on the screen is in the HL register. The source code, the source for the image is in DE, and B and C are used as masks for the left and right sides. So essentially that's how we do it, and I use the accumulator as a counter for the loop. So that's why we put that on the stack at the beginning. So all we do here is essentially get the first byte, and then we mask it off as I explained when we were looking at ZX Paintbrush, and we then put that onto screen. And we well, actually no, I should say we don't put it on screen yet. We check with what is on screen to see if there are any pixels there. If there are, then it basically means that the player character is in that space, which means that there is a collision, which basically means that it will exit at that point and player will be killed. So it's a collision detection which basically runs as the sprite is being drawn, and we do that each time. So we just mask it, and then we check if it's hit, and if it hasn't, we bring it back, then we mask it again, then we draw it to screen safely like that, and then we load that into screen. We then go across 2 squares because the first byte is the left hand side of the byte, if you see what I mean. Now, not the middle section, we're going to draw the right hand side section. So we go across 2 squares, we get the next byte, it's the same byte I should say, and then we mask off the other side, and then we basically do the same check again. So we've now drawn the left side and the right side, and then finally we go to the middle part and we load in the second byte, and that is basically then drawn to screen in the middle, and so that would then draw a full line. And after that we then move down 1 line and we go back to the loop and we restart, and it goes all the way back until it's drawn all 16 lines. And I think probably the best thing I can do is to show you again roughly how that works within the game by using ZX Paintbrush, and I'll show you that now, just a second. Okay, so here we are back with ZX Paintbrush, and here is our source data, which we want to transfer from 2 character squares into 3. And in the previous example I said that we draw this, then this, then this, because obviously that would be a logical order. But actually what actually happens is, let's say we want to draw it here, 1, 2, 3. So we're starting here, and basically we take this byte. This is what would be happening in the code, but it would be happening line by line. I'm going to do it with a whole block just because in terms of showing you what's happening it's easier for you to understand, but it does it line by line. But essentially this is the principle. It starts with this byte, and it would then mask off, before it prints to screen, it would mask off this half, and then it would print this to screen. Obviously it would check, it would do a collision check, and then once that was confirmed, that would be done. We then step forward 2 spaces, and we still use the same byte, so that means we're still here, because we don't want to have to step forward and step back again. That would waste time. So, and then we step up like this, and we put this one into here, and this time we mask off this area, and that basically goes into there. Now this byte is finished. We take 1 step forward in the source here, we take 1 step backward in the source here, and we draw the middle section like that. And this is done line by line. So obviously, so we draw this part, and we jump forward, draw this part, and then we draw this part, then we step back a line, then we go down 1, and then we do the same thing again, and it all goes through like that. And that's basically how we draw a sprite within a space of 3 rather than 2. So basically, when people talk about hardware sprites and software sprites, this is basically software sprites. It means that we've written code, assembly code, in order to create the impression, at least, of a sprite being on screen. And that's done by manipulating the bytes themselves and pushing them onto the screen in the ways that I've shown. So I hope you found that interesting and informative. I have plans perhaps to do more tutorials in the future that explain how you actually code this kind of thing in assembly. It's not nearly as scary as it first seems, and I hope this video perhaps helps you to at least begin to have an interest in that. Now, before I finish then, we'll talk about what we're going to look at in the next vlog. And here we are. I'm sure some of you will be glad to know that I am returning to Invaders, and I have now got a routine which will cause bullets to be generated by the invader that's closest to the player. This is the sort of intelligent AI, sort of semi-intelligent, let's say, AI for the system. It will drop a bullet in the appropriate place, and the collision detection is not complete, as you can see, as it's going through the bases. But we do have collision on the player, which does work, so that's a start. So we'll talk about that, and we'll have a look at some of the routines that we do that will allow the bases to be destroyed and the bullets to be shot by the player, and then finally how to add the other bullets. And I think once we've done that, the main essence of the game will be more or less done, which is great. Okay, so I hope you enjoyed it, as I said, and keep enjoying the Spectrum. Best wishes and good health to you all in these difficult times. As always, happy coding. Bye bye.